We're back. Did you miss me? We're
Yes.
we're gonna persist. It's not just me going away. You're all going away too, and then we're coming back. Is that what's happening?
Yeah.
Okay.
Yeah.
All
Yes.
right. We're all in this together. Carol, it's gonna be an interesting recording. We'll keep it. All right, we'll start again. So as I was saying, Flathead Lake in Missoula is I think it drains into the Clark Fork. And so during the last ice age, get back on my keys here, Flathead Lake, the drainage was
Paul, can
blocked.
you back up? Can you back up about 2 or 3 slides? I think we lost you
Sure, sure,
earlier.
sure, sure. Okay,
Thank
I
you.
will do that. So I would, this is where, this is the transition, me explaining that the Portland Basin, here we go.
Yeah, that's where you're at.
That's where I was at? Okay. So you saw the dike, and then I was explaining that the basement rock in the Portland Basin would be Siletzia, then CRB on top of that, then river sediments, including the Missoula sediments, and that takes us to 3 orders of magnitude closer in time. We're talking thousands of years now instead of millions of years, but one of the last ice ages. We go out to Montana at the Flathead Reservation of Confederated Salish and Kootenai tribes, are partly in the Flathead Lake region, and they have stories about tremendous floods that occurred out there. Apparently during the last ice age, this is the story we all tell, we all know pretty well, giant ice sheets, continental glaciers invaded the United States from Canada and blocked the Clark Fork drainage, turning Flathead Lake into glacial Lake Missoula, with an ice dam that broke numerous times, at least perhaps 100 times, each time flooding the Columbia Basin with water and ice and rock and debris. Okay. So then that was what carved out the channeled scablands and dry falls. And this is going to bring in the conversation that we were having before the hour with Nancy about Nick Zentner and the work that he's done with Randy Lewis of the Colville Confederated tribes out there. They have coyote stories, which it's not really my place to tell, but coyote stories of warning people to stay out of the lowlands. And so there's some evidence there that there was, again, Native American presence, at least at the latter end of the Ice Age, which is more closer to 14,000 years ago or 12,000 years ago. I always get confused with the BC designation. But the water then continued through the Wallula Gap and again followed the path of the Columbia through the Cascades, flooded into the Willamette Valley in Portland. And the Kalapuya, according to Dr. David Lewis, have accounts of an interior valley flood of this magnitude. So then the water pooled in what we call temporary Lake Allison and slowly drained out to the ocean over days or weeks. This is a inundation map of the city of Portland and Vancouver, showing the extent of the water inundation, which was to a height of 400 feet. So this stuff comes charging through the gorge at 60 miles an hour. And Gail Woodside down at U of O has done some work to show, I'm sorry, OSU, show that the people were making cedar ropes at that time that might have been able to hold the canoes fast. So there might have been, it's reasonable to assume that there might have people stuck on the top of these buttes or who managed to get away. And it would have been a terrifying experience, but it was probably, at some point there were probably survivors. So looking at a geologic map of the Portland Basin here, the pretty blue and red colors are volcanics, but we're going to focus on those 2 colors of brown, which indicate Missoula sediments. As the water charged out of the gorge at 60 miles an hour, it slowed when it entered the basin. And in slowing, it dropped its first load of the heavier stuff, the gravels and boulders. So what it leaves behind are these graded beds. I'm getting a phone call because I forgot to turn off my phone. Boy, it's just been one thing after another today. It leaves these graded beds. Here's another exception to the rule that sedimentary structures are always perpendicular to gravity, because you get these what are they called? The name is dropping out of my brain at this point, but you get these diagonal beds that form. It's very indurated stuff. It's very tough stuff. Good place to be in an earthquake. Where
Foreset beds.
Thank you. Where the water slowed and had a chance for the sand and silt to settle out, we get a different phenomena. We get these rhythmites. And this is from the work of Scott, I think it's one of your students, David Jones, looking at an outcrop on Greeley Street. What you get are what we call graded. Are they graded beds? They're rhythmites, where first the lighter gravel drops out, and then you get over time the sands and silts drop out, and that's one flood, that's one rhythmite. And then you get maybe a smaller flood, another bed of gravel, and then sand and silt, and then so on. And this is how we know that there have been up to 40 Missoula floods that made it into the Portland area and Willamette Valley. So this is a video that sort of shows the process. It's a little sticky. I'm going to have to coax it along. Oops, nope. Try that again. So if you're asking yourself, why is Paul so fascinated with this, this overlapping? I mean, what you see there is you've got this again and again. You've got gravels and then fines and gravels and fines, and you've got erosion in between, and 15,000 years of erosion afterwards, plus millennia of human habitation as well. Well, this is the reason that one of the reasons I'm so fascinated with it is that I live right here. Next to Reed College, and to the east of me are Missoula flood, coarse grain Missoula flood deposits, and to the west of me are fine grain deposits. That is important for a reason I'll mention in a moment. Now, the diagnostic rock here, when we're looking for this, when we're looking for things that came down the Columbia, whether Columbia sediments or Missoula sediments, the one we're always looking for are these little quartzites. They tend to be orange, though not always. They have this sort of sugary quality inside. And they are metamorphosed sandstones, so they're very old, maybe as old as 1 billion years. This had to be sand that was, washed into the sea and then covered up by a continent and metamorphosed. And in this case, we know, and I know, thanks to Scott, that this probably came from the Montana Fold Belt, and it had to be washed down into the Columbia Basin and eventually the Columbia, either by the river itself, or more likely in the case of stuff that's around me, Missoula floods. Okay, long story short, the other thing that subduction domes do is they get stuck and unstuck with catastrophic earthquakes periodically. There are Native American accounts of thunderbird and whale that go back millennia that appear to be accounts of tsunami and other earthquake phenomena. But in Western science, we didn't know that there were earthquakes in the Pacific Northwest. We knew that from 1906 on, we knew that they were in California. California is kind of ahead of us on this. Another clue were these ghost forests at the Oregon coast, which at low tide, if you look at those dead tree stumps and you do the dendrochronology, looking at the tree rings, you'll see that they all died in the same year. They all got flooded out as the land dropped and the tsunami brought sand in, killing their roots and killing the trees the next season. But the big clue, of course, was the Orphan Tsunami. Japanese keep very tight records of tsunamis and their connection to earthquakes, as in the tragic Tohoku earthquake of 2011. And usually there's a very tight connection between the earthquake and then, say, 15 minutes later, the tsunami comes. But there was one in 1700 that didn't, there was a tsunami in 1700 that didn't have an earthquake associated with it. And this is the so-called Orphan Tsunami of 1700. So scientists have determined, by turning the clock back and assuming that tsunami waves travel at about the speed of a jet plane, 500 miles per hour or so, that the last catastrophic earthquake in the Pacific Northwest was January 26, 1700 at 9 p.m. Now, I think the 9 p.m. is kind of them showing off, but the point is that on average, looking at the last 10,000 years and the geologic evidence, we see we've had a magnitude 8 or 9 about every 300 years. Well, 1700 is now 312 years ago, so this is why many geologists say that we're 9.5 months pregnant for the next catastrophic earthquake. Why this is important to all of us in Oregon, but why it bears on my thinking, why it is something I worry about. This is the geologic map again, and I'm going to overlay liquefaction hazard map on it. Pretty much what you think. Red is bad. The worst is this artificial fill bound by the river, which was fill that was dredged up from the bottom of the river and filled in the floodplain back in the early 20th century. Biggest concern there, I think, is that's where we have our critical energy infrastructure for the whole state, including tanks, some of which are 100 years old, that are on liquefiable fill that in an earthquake will liquefy, the tanks will fail, catch fire, releasing toxic ammonia and chlorine and other toxic smoke, and then float downriver, causing environmental catastrophe. This is something that former engineer at Dogami, who's done a lot of work on this, Yume Wang, has recently addressed as a major environmental justice concern for historic Black neighborhoods in Northeast Portland. And for all of us on the east side, because, hey, the westerlies bring, the wind goes this way. And so all of Portland is at risk from the threat of the critical energy infrastructure. Less worse place to be are on those fine sediments. You're pretty okay there, but that's going to depend on the moisture content in those fine sediments. And as I say pretty okay, I want to remind you, I'm not a professional geologist. If you're concerned about the safety of your home and the chances of liquefaction, consult a professional. The best place to be probably is on those graded, those foreset beds of gravel. The good place to be if in an earthquake, although because there are lots of gravels, lots of things like granite that were brought down from Canada, a higher proportion of radioactivity, slight, but enough to cause radon. So check your basements for radon. There's my house right on the border between those fine sediments and those gravels. And that's one of the reasons I am so fascinated by this issue. And this is not an ad for Simpson Strong Tie, although they did sponsor one of our events recently. But this is what I've done in my own home to make sure that my house stays on its foundation and we can shelter in place after an earthquake. So that's the, wait, but there was one other thing I wanted to mention, or you're saying, what about that character you introduced earlier in the story, the Yellowstone Hot Spot? What happened there? The deal with hotspots is they tend to stay in place or we believe they stay in place while plates move over them. So in the case of Hawaii, you have these older and older volcanoes and islands as you go to the west, all the way up the Emperor Seamount chain, and younger as you go to the east because the Pacific plate is moving over the hotspot. In our case, as you recall, we have Silesia as the oldest we know about, 56 million years old, and then docked 50 million years ago. Then we've got some more recent, the Waverly basalts, and those of you who went on some of our local field trips, you might remember us finding these down in Milwaukee, and these are about 40 million years old. And then we move to the center of the state. So the plate now is moving, the North American plate is moving over the hotspot, so there's a general eastward trend here. Hotspot staying in place, the plate's moving over it. We got the Crooked River Caldera that we experienced on our last trip out there to Blue Basin, and the folks out there, God bless them in the heat. I hope they're doing okay, but that's they're out there in those that area of volcanics from about Eocene age. And then there's a period before we get the Columbia River basalts, the Picture Gorge basalt, steam basalts about 17 million years ago. And we move into some of these super calderas about 16 million. And then notice it's just this track backwards, 12 million, 10 million years old, you can see where this is going until we get to the Yellowstone Caldera 600,000 years ago. So that's the story that brings all of this together, is that Yellowstone Hot Spot interacting with a subduction volcanism. And boy, you know, when I see my wife is here, when we joined the Geological Society a decade ago, I don't think we knew this. I'm sure the experts did, but this has been a fascinating piece that has developed and is now sort of at the forefront of geological science. And we're learning more and more that simplified diagram I showed you of subduction is, well, this looks like it's decorated for pride, but this is more of the work of Caroline Siglock using seismic tomography, basically like a big MRI looking into the Earth's, underneath the Earth's surface. We're seeing that it's just a lot more complex and interesting than we had thought before. One of the delights of working with the Geological Society has being able to be shoulder to shoulder with some of our experts who are actually doing the work and out there in the field. In particular, Dr. Emily Cahoon was with us last month. This is on our website if you want to watch her lecture, but she's out there leading a field trip right at this moment, talking about the relationship of sunstones to those picture gorge basalts. Come next month, or actually it's only a few days away now, Friday, July 9th, we'll have Leslie Moklock talking about her new book, Rocks, Minerals, and Geology of the Pacific Northwest. And we remember her from when she was curator out at the Rice Museum. This is a beautiful book. Pick up a copy if you are interested, or just come to the lecture. That's available through our website at gsoc.org. One last thing, we can pat ourselves on the back as the Geological Society, because not only did we contribute to saving the State Department of Geology and Mineral Industries from the governor's axe earlier in the legislative session back in the winter, but partly because of the work of one of our members, Yumei Wang, and others like Clark and Sheila Alfson, we have succeeded in getting an earthquake resilience specialist refunded in the department for the tune of what you can see there, $328,000, that is now going to go toward restoring that scientific position. So if you're in GSOC, congratulate yourself for being part of that lobbying effort, which has been very successful. And we appreciate everyone's work on that. I'm going to stop there. I'm kind of, well, Zoom hasn't kicked out again. So we will resume our in-person meetups, and sometime we're going to figure that out. Clark and I will talk some more, and we'll get back to the deli once it opens up. And we're going to keep doing these Zoom meetups too. So I'm going to stop there. Carol, you can turn off the recording. I don't know what it sounds like now with all of the interruptions, but.
Well, Paul, I don't have ability anymore. I think I lost.
Oh, okay. Okay. Well, that's okay. I think we all did well. Thank you all for your patience. And I will stop sharing.
Can you go